Hello everyone, I am Thenuka Karunathilake and together with my colleagues Anna Froster, Asanka Udugama and Jens Didi would like to present our work to you on benchmarking data dissemination protocols for opportunistic networks. During this short video, I would like to cover following topics very briefly. First, I will be giving an introduction into opportunistic networks. Then I would like to talk about our motivation behind our work. Then I will be talking about our developed benchmark scenarios and our online simulation as a tool, the OOTB. At last, I would like to do a short demonstration with OOTB and with these developed benchmark scenarios. First, let's start with the introduction into opportunistic networks. Opportunistic networks are certain type of networks which do not have continuous connectivity between nodes, and when the opportunity arises, they create the network. Therefore, we can say opportunistic networks rely on intermittent direct contact between nodes to exchange information. There are many applications available with opportunistic networks, such as post-disaster communication, communication in remote areas, tourist group communication, and vehicular communication. Let's move on to the motivation. There are many research done in the area of opportunistic networks, and most of them are focused on developing reliable and low overhead data dissemination protocols, which is obviously a good thing, but with this we identify a certain problem. All this research work and authors tend to use self-defined application scenarios to suit their developed data dissemination protocols. That means if we select 10 different publications, they will have 10 different scenarios with different number of nodes and different simulation times, and again different traffic generation patterns, which means very low cross comparability between these research work. This is exactly the problem that we are trying to address and solve with our work. As a solution, we are proposing a new set of benchmarks developed specially for opportunistic networks. We expect these scenarios to act as a set of standard scenarios by allowing researchers to have a common realistic set of scenarios. And we think this will enable reproducibility and cross-comparability between protocols with a rank-based system. And we also believe that this rank-based system will offer competition-like environment for researchers. When it comes to scenarios, currently we have 11 different scenarios developed with 6 different real-life traces. This table gives the current overview of the benchmark scenarios. We have 6 different real-life traces, and all of these traces are with different number of nodes and simulation times. As shown in the table, the node numbers are ranging from 49 to 3600 nodes, while simulation time differs from 3 hours to 7 days. We selected this variety because we needed to develop a set of realistic scenarios, and again we wanted them to be diverse as much as possible. We are actively gathering more traces and hoping to increase this number of scenarios in the near future. When it comes to traffic generation pattern, in most of the cases we had to handcraft the traffic information because we did not have any other option, because these traces only contain the mobility information. But when it comes to this typhoon scenario, it was a special case and it was taken from Twitter, and it already had the information about the timing of these tweets. Therefore, in that case, we use these timings to inject packets into the network because to make this scenario more realistic. Next, I would like to show one handcrafted traffic pattern with taxi scenario. This figure shows the traffic generation pattern, and again we created 2 cases with high traffic indicated with this red solid line, and low traffic case indicated with this blue dotted line. The y-axis indicate the frequency ranges between packet intervals, and the x-axis indicate the 24 hours of one day, and this pattern is returning for the total duration of the simulation. The traffic pattern is changed during the day according to the expected and imagined real life incidents. For example, during morning hours we expect more traffic than during early mornings. To add more reality, we added some special event to mimic such events like accident or maintenance. In such realities, suddenly the number of traffic will increase abnormally. So if you are interested about these scenarios, you are welcome to visit this link, and there you will be able to get much more details. Now I would like to discuss about our newly developed online simulation as a tool, which we called OOTB, which stands for Oops on the Bench. All the previously described benchmark scenarios are now developed into this OOTB, and OOTB has a web-based interface to start simulation and a back-end to run and perform simulations. This back-end incorporates several mechanisms to run simulations. To run opportunistic networks or opportunistic simulations, we are using our own opportunistic protocol simulator, and it is built with Omnet++ and iNet framework. We are using Docker to host Linux-based instances of OOPS and Omnet++. And again, for more information about this implementation, please use the following link. And now I would like to do a short demonstration into OOTB. To log in or to go to this OOTB, please use this link. When you use that link, first thing is you will be asked to log in. So now I will be using my credentials. So when you log in, you will see this interface. So in here, to run a simulation in OOTB, you have to use this Start New Simulation tab. In here, you have two options. First thing is you can run a simulation with already available Omnet ini file. And second option is to generate an ini file using the generator. But for now, we don't have this option, so we will be using this option number 1. And then you will be in step number 1. In here, you have to put a simulation title. So I will be putting a number here, and then you have to select for the simulation file. So I will select my ini file, and if you look at into this ini file, it contains all the information regarding above mentioned benchmark scenarios, such as simulation time, the number of nodes, and the forwarding protocol information. So after you select your ini file, just click next, and you will be going into step number 2. In step number 2, the first thing is the precision. By default, it is set to 100 seconds. That means every 100 seconds, the results will be gathered into a vector file. The second thing is an email address where you can set it to get the notifications from OOTB. The third option is to select the simulation that you need to run. So in here I will select a small simulation. I will select benchmark 11 roller skate scenario with low traffic. Then just select next. Now the simulation is started. To get the status values or to get the status, just go to this job status. So here you can see now the simulation is started. The test number 12 is started, and it will take some time to run. Okay, now the simulation is finished, and to get the results you can select the job ID, and then you will be directed. Okay, so here you have the details of the simulation for test 12. Here you can see the peak RAM usage during the simulation and results passing, and again you can see how much disk usage has been used. To get the simulation results, you have to go to this download results, and then you will be directed into a Dropbox links. In here you can get all the information or all the results regarding that simulation that we just ran. So here you have the CSA file, and inside here over 50 different parameters are selected. So you can select any file you want, and in this graph file all that parameters are indicated in graphs. So this is the end of the small demonstration, and I would like to wind up the presentation from here. Thank you for your attention.